here we are solving problem 416, which is calculating the resultant couple. It means that here we have 4 forces, but as you see, these 2 forces are parallel and the same magnitude and in opposite direction. So this is one couple, and here we have 2 forces, also same magnitude and parallel and opposite direction, right? So therefore, opposite sense actually, right? Because one goes in one direction, another one points towards the other direction. And we are asked to calculate the resultant couple. So the resultant couple, which is a free vector, it means it doesn't matter where you calculate the vector, it will give you exactly the same magnitude, and that's a particular property of a couple. I can say that the resultant couple will be the couple done by couple 1 and couple 2. Let's label this one here couple 1 and this one right here couple 2. So let's calculate the moment produced by this couple of forces and then this one right here. Very important, we said that the moment produced by a couple is the distance times the force. So if I have a couple of forces, is this distance times the force, and the direction will be given regarding the direction of the forces. In this case, the couple will be in this direction, right? And these two have to be perpendicular. So if we see these forces, we will have to find this perpendicular distance, or we could do it in a different way. We could find the vertical components of these 2 forces and use this distance that is already given. That's an easier approach because we have this angle and we have this distance. And the x components of the forces, as you see, are the same magnitude and looking in the opposite direction, so they will cancel out. Therefore, this moment over here will be equals to the magnitude, which is 50, and times the cosine, which allows me to find the vertical direction, times the distance. So let me write the distance first, and this distance, as you see, is 3 feet. So that will be 3 times only the perpendicular component to that distance, which will be 50 cosine of 30. And that gives me a value of 43.3 pounds per feet. So as you see, and as I said, the component, let me write it right here, component in x direction, which will be 50 sine of 30, right, does not contribute. To moment. Okay, so that's the moment produced by this couple. And which is the direction? As you see, we have this goes in this direction. So I put my hand in one of the origin of one of the forces and go to the other one. So this moment is clockwise. Since it's clockwise, we have to say that it's negative because our convention is that this is x, y, therefore clockwise is negative and counterclockwise is positive. Okay, so we got a negative value. What about the second moment, which is this one right here? Moment produced by the second couple. We will do the same. We will find the components that are perpendicular to my distance, and we also find the components that are parallel. And as we see, the components that are parallel to the distance don't contribute to the moment. So I will use this distance, which is 4, and I will only use the component that is perpendicular to the distance, which I have to multiply by the cosine of this angle. And the cosine of this angle is 4/5. Therefore, I have 4 times 80, which is the magnitude of the force, times 4/5. And that gives me the value. I will analyze the value. That's 64 pounds per feet. What is the direction of this moment? Let's find out. So I put my hand right here in one of the forces, go the direction, and point my fingers towards the force. So as you see, this moment over here is counterclockwise. So it's positive, right? So this is negative, right? So therefore, finally, my resultant moment will be the multiplication of that negative and the multiplication of that positive. And that gives me a value of negative 129.9 plus 256, all that pounds per feet. And as we add those two values together, we get 126 pounds per feet, and the direction it gives me positive, therefore is counterclockwise. This is the result of this moment. So this multiplication gave me a value of a negative 129.9, and this multiplication gave me a value of 256 pounds per feet. And this is the solution of this problem. The most important part is that in this case, the component in x direction did not contribute, and in the case, the component in y direction did not contribute, because they cancel out and because they are along the distance that is between the two forces. And the only component that contributes to the moment is the one that is perpendicular to the distance.